Okay, so it says solve the triangle. That means find all the angles, find all the sides. So everybody should have a calculator out so we can go quicker through the problem. So everybody look, we need to find angle B. Angle B. We need to find side C and side A. Notice, couple things to notice. They always write angles as capital letters and then sides as little. So angle or side C and side A. So everybody, how can I find angle B? Very easily. 180 minus 90 minus 34.2. Cool. Angle B is 55.8 degrees. Now look at this. I'm going to go ahead and set up a trig ratio to solve for side A, or C would work. I'm going to go with A. Opposite, adjacent. So what am I true? Statement B. Tangent of 34.2 is equal to A over 19.4. Then you say I'm going to solve for A, so I'd multiply up by 19.4. I do want to say one thing though. Your ACT will leave, the ACT says this, you can solve every problem on this test without a calculator. Therefore, they could not say that and not have that be true. So notice, to find this exact answer, because that's not an angle on the unit circle, we would have to use our calculator, right? So the ACT would either leave it like this, or they would make sure to give you an angle that's on the unit circle. So as you go into your ACT, that will help. That if you get a trig problem, to get an exact answer, it will be on your unit circle, or it'll just leave the answer like this. Okay, go. Type it in. It's not on the unit circle, so we'll type it in. Side A is, can't be negative, so either our calculator is not in degree mode or something. What is it? 13.2. Is that what you're saying? 13.2. Now, to find side C, wouldn't you just use Pythagorean theorem? Okay, so do it. 13.2 squared plus 19.4 squared, and then the square root of that. Pythagorean theorem now, right? So we already found B. See, we found B. We found A now. So now to find side C, we would do Pythagorean. Thank you. 4, 6. Okay, cool. Moving on to the next problem. It says, a safety regulation states that the maximum angle of elevation for a ladder is 72 degrees. A fire department's longest ladder is 110 feet. What is the max safety rescue height? So draw a picture, ladder. Angle of elevation, isn't that this angle? 72, this is 110 feet long. It says, what's the maximum height? So you'd say, oh, it's a right triangle. So I'm going to set up a trig ratio, opposite and hypotenuse. Sine of 72 is equal to opposite over hypotenuse. And then wouldn't you just multiply both sides by 110? So 104 feet-ish. 0.6 feet. Cool. Not very tall. All right, now this is where it gets a little bit more involved. It's not super bad though. It says, at a point 200 feet from the base of a building, the angle of elevation to the bottom of a smokestack. So a smokestack is like a little pipe that leaks out the smoke into the air. So the angle of elevation to the bottom of the smokestack is 35 degrees. Now it says the angle of elevation to the top of the smokestack is 53. It asks you to find the height of the smokestack. So do you see how we don't know this height or this height? So we actually have two separated right triangles. I always go off and draw them. Look, I have a small right triangle right here with a 200 here. The side here across is A, and this is a 35 degrees. Does everybody agree? Then I have my huge right triangle with this side length being A plus S. This angle being 53, and then still the length is 200. So now look at it. If we're trying to find if we're trying to find S, couldn't we first go over here and say, let's find A first? So opposite, adjacent would be, so you'd say tangent of 35 is equal to A over 200. Therefore, A is 200 tangent of 35. What is it? And let's do the decimal. 140 point. Okay, cool. So now look at my next triangle. Do you see how we only have one unknown now? So we can go through and set up another trig ratio, opposite, adjacent. So you'd say tangent of 53 is equal to, my opposite is 140.04 plus s. My adjacent side is 200. Now solve for s. So you would have 200 tangent of 53 equals 140 plus 140.04 plus s. So then, yep, you'd minus it. 200 tangent of 53 minus 140.04 equals s. What is 100 and something? 0.17? I don't know why I can't hear. Sweet. Was that pretty easy still? Hey, we're almost literally done with the lesson, so stick with me for a minute. It says a pool. A pool that is 20 meters long has a shallow end of 1.3 meters. So I'm drawing the picture here. So here's the shallow end of 1.3. It says then, so the deep end is 4 meters. What is the angle of depression to the deep end of the pool? Well, remember, so if you look at this picture here, can't we drop down and say, well, if this is 20, this is also 20. And then we have a right triangle right here, don't we? And then what's the length from here to here? 2.7. If this is 4 and this is 1.3, that is 2.7. And then just set up a trig ratio, opposite and adjacent to find theta. Remember that angle of elevation and depression are the same. So we would say tangent of theta equals opposite 2.7 over adjacent, which is 20. And then you'd say, I need to get tangent alone. So I would tangent inverse both sides. I need to get theta alone, is what I meant to say. So we're going to tangent inverse both sides. So theta equals tangent inverse of 2.7 over 20. And then keep in mind, we're finding a degree, so it needs to be in degree mode. So guys, that means it's getting like, look at how I drew the angle. I drew it going really quickly, right? Getting deep quick. It's going really slower than that. You don't know until you drew the picture. So it's growing down slowly, yes. Because our true statement was, great question, tangent of theta. And in this one, we're trying to get theta alone. It's trapped inside tangent. Yeah. You'd have to open up that tangent, yeah. Okay, this is where you have not learned. This is the end of the lesson right here. Focus. This is what you have not seen before. And it is different, really different for me as well. It's kind of hard for me to think about, to be honest. So trig bearings. So this is like if you go on a ship on the ocean, you have to be able to have a compass so that you don't get turned around. So your compass will tell you where north, south, east, and west is at all times. Now to describe where you're at any given time, you're going to have to describe it in a way. Think about it. If you're sitting in the middle of the ocean, how are you going to describe to someone how to get to you or where someone is? Well, they do it with these trig bearings. So they always explain their directions reading clockwise from the north. So right here. So north is where your eyesight starts, and then you're heading westward at an 80-degree angle. So that means starting north, you're then heading westward at an 80-degree angle. Does everybody see? That's different than we're used to. Does everybody see how that's kind of weird feeling? So north, heading 80 degrees west. Because the north just tells them where the eyesight should start on their compass. And then they know, oh, you're now going 80 degrees west. And they actually have these special compasses where they can then click 80 degrees from the west. So they know they can head in that direction. And it tells them you're now heading 81 degrees. Because that, after a while, would be a long... Yeah, so it tells them you're now steering off course by a half a degree. Get back on it a bit. So yeah. So this is south. I meant to go like this, I think. South, 35 degrees east. I meant to put east over here. So heading south, your eyesight south, and then 35 degrees east. So that would be like this. Everybody good? Okay. North, 45 degrees east. So north, and then heading 45 degrees east. So this would be 45 degrees. Okay, here we go. Now we're going to use that knowledge. So let's draw. The hardest thing is honestly drawing these pictures. So everybody, we have done this wrong first hour. We then I fixed what the wrong that we did first hour. We did it again wrong second hour. Let's get it right in this hour. We're all smart people. I need you to help me. I'm going to be honest. Trig bearings are hard for me. So it says, oh, wait. Hold on. We're going to push pause and fix some. So the ship leaves port at noon. Now, first of all, I kind of go off to the side and draw to remind myself north, south, east, west to kind of help myself keep a good visual here. So it says at noon. So I'm going to start right here. This is where we're starting. That's 12 o'clock noon. The ship heads due west. So I'm going to draw that. They're heading this way, due west until 2 p.m. So boom, they stop at 2 p.m. They then change and course to north 54 degrees west. So now let's draw where that would be. First of all, I would draw my north. I would draw my new little north, south, east, west thing. And then if they're heading westward at a 54-degree angle, so like this. So from the north, wait, where was I? 54 degrees west, so that would be this distance, right? So right there's 54 degrees. Then it says at 3, tell us the distance that they will be at 3 p.m. So now think about it, guys. Couple things we can put in more. So we're stopping at 3 p.m. and answering their question. They want to know the distance from here to back to the starting point, the port, and then they want to know the new bearings. So let's first of all look at this triangle. Is it a right triangle? No. First of all, though, we do know this length because it said 20 miles per 1 hour. So how many hours took place here? So how many miles? 40 nautical miles. That just means like miles on the water. So that's a distance of 40 right here. From 2 to 3 was 1 hour. So wouldn't they have traveled 20 miles there? But now the problem is it's a non-right triangle. So if you think about it, though, we can take and drop down and create a 90-degree angle right here. So we have a small triangle. Now we don't know that. We have no idea what this is. But we can figure out what this angle is, because isn't this a 90-degree angle? So good point. This is 36 degrees, everybody. So now looking at this, if you notice, within the small right triangle, we also have this big right triangle where we could eventually possibly use Pythagorean theorem. So let's go off to the side and do some math here on this small right triangle. So on the small right triangle, I have this. I have 36. I have a 20. Can't I find this and this? Let's do it. So let's set up a true trig ratio here. So from 36, we have opposite and hypotenuse. So we would say the sine of 36 equals question mark over 20. So question mark is 20 sine of 36. So what is the height? Okay, 11.76 right there. Okay, good? So this is 11.76. And now let's do Pythagorean theorem to find this value right here. So you would do 20 squared minus 11.76 squared equals x squared. And then you would square root that to find this distance as well. Thank you so much. You guys are being so fast, and this is going so much better. So now if you think about it, we have this big right triangle. I like to redraw what we're looking at for a second. So we know this is 11.76, this is 90. This distance will be 40 plus 16.18. 56.18, right? So now we can find that distance pretty quick. Pythagorean theorem here to find that. So our first answer is what? Okay, cool. 57.39. And that's nautical miles. So I'm going to highlight that. So now this is what's hard. We have not got this right in any of the hours. Figuring out the trig bearings. It says find out the new trig bearings, the ship's bearings, and distance from the port of departure. So now what we're doing is we've got to find the new this from this, right? Now here's my question. Do you guys think it's from where the ship's at back to here, the trig bearings, or do you think it's here? It's there. Okay, so let's draw. So that's what we're looking at, right? I know, it's hard. So we have to find this angle, right? Because it goes from the north. So we have to find this angle. Oh, okay. So I like your idea. So take 180 minus 36 minus 54 to find that angle. Is that what you're saying? Oh. Good idea. So on this triangle, you're saying if we find this angle, we then would just subtract it from 90. Smart thinking. No one's thought of that so far. Let's do that. So now that's a little theta. So now opposite and adjacent. Wouldn't that be tangent? So you'd say tangent of theta equals opposite 11.76 divided by adjacent 56.18. So do tangent inverse to find that theta. So if you wouldn't mind doing that. That's exactly what we should do. Way to go, guys. See, I knew I could count on this class to help me out.
Do you hear that video? You like this more?
11.82 degrees. So now take 90 minus 11.82. So 70.18. So this is what we would say. That's that angle right there. You'd say north and then heading 70.18 degrees west. What? What was the decimal? So the 0.18 is good, right? Yeah, so now we just need to fix this. So north 78.18 degrees west. Woo! Woo! Okay, Patsy. Super talented. Okay, that was funny. Okay. Yeah. Hey, there's the lesson, but you're not doing 43. Good job, guys. That's the end.